Today, we will use a scientific perspective to explore the complex truth behind meteorological events. According to the latest news from the New York Times news website, on the afternoon of February 9th, a small plane carrying 5 people crashed on Interstate 75 near Naples, Florida. Photos and video footage from the scene showed the plane's fuselage on fire and thick smoke billowing from the crash site. Flames shot into the air and engulfed the plane, leaving a damaged car parked on the median. Witnesses said they were driving on the highway when the plane came up behind her and the pilot appeared to be trying to land on the highway. Terrifyingly, she hit the roof of a pickup truck in front of her, narrowly hit the highway, skidded about 30 feet, hit a concrete wall, and burst into flames. About a minute after the crash, the plane exploded. The Bombardier Challenger 600 aircraft, which had 5 people on board, collided with a car, according to the Florida Highway Patrol. 3 of the people on board successfully escaped from the plane. After the crash, drivers stopped to try to help, but the ensuing explosion sent people running for cover. Thank you for liking, leaving comments, subscribing and turning on the little bell. We will update every day. A 6-mile stretch of Interstate 75 will be closed for at least 24 hours, with local officials encouraging people to avoid the area while the FAA and National Transportation Safety Board investigate, according to the Collier County Sheriff's Office. The Florida Highway Patrol was also on scene. The National Transportation Safety Board said in a statement Friday that preliminary information showed the pilot reported over the radio that the plane was experiencing twin-engine failure as it approached the Naples airport. More than 2 hours after the crash, highway cameras showed dozens of vehicles stuck in traffic, unable to get around several law enforcement vehicles at the scene. Officials said the plane, registration N823KD, was due to fly from Naples to Fort Lauderdale on Friday afternoon, according to flight tracking website FlightAware. The aircraft, which can carry up to 12 passengers, is part of a fleet maintained by HopaJet Worldwide Jet Charter, a private jet travel company based in Fort Lauderdale, Florida. In the history of human aviation, accidents involving twin-engine failures have made it extremely difficult to land safely and survive. The primary factor is bird strikes, which can cause twin-engine failures in detail. When large flocks of birds are sucked into the engines, they can damage turbine blades and destroy compressors and other rotating parts. This results in an immediate loss of thrust. In addition to direct physical damage, bird strikes may also damage the lubrication system and cause related cascading failures. Secondly, it may be that the engine is icing. The formation of ice will block the inlet, change the airflow path, reduce the turbine speed, and thereby reduce thrust. In severe cases, it can cause the compressor to stall. Icing depends on weather conditions such as temperature, humidity, and the time the aircraft spends in the clouds. Mild ice can be relieved by a vent or rubber bulge pulse system. At the same time, it may be due to mechanical failure. The main examples are main bearing damage causing rotor locking, turbine blade fragmentation causing imbalance, and sensor failure causing erroneous indication and control. These consequences can be mitigated through design redundancy, physical isolation, and multi-channel monitoring. In addition, it may also be due to interruption of fuel supply, mainly caused by pipeline blockage, pump failure, gas generation, air rendezvous failure, etc. Contamination such as water or particulates can reduce combustion efficiency and eventually quench the flame. The impact can be mitigated through multiple oil supply systems, filters, and quick switching. What cannot be ignored is human error. Improper maintenance such as failure to change the lubricating oil, operational errors such as incorrect parameter setting, may lead to double engine failure due to chain reactions. This requires a complete maintenance and guarantee system and strict training and assessment to prevent it. When faced with the extremely rare situation of dual engine failure, the crew will initiate detailed emergency procedures as soon as possible. This requires them to maintain calm judgment, accurately coordinate communications with air traffic control, and choose the best airport or alternate location for landing. At the same time, the ground is notified to prepare for emergency rescue. Throughout the entire process, the captain's command is extremely critical. He must comprehensively consider many factors such as aircraft status, route orientation, weather conditions, fuel limitations, terrain environment, etc., and make optimal decisions quickly but accurately. This requires training and experience. At the same time, the co-pilot must assist in shutting down the engine and related systems, reducing the flight load, reducing the speed, and making every effort to prepare for the final approach and landing. Flight attendants must quickly instruct passengers to fasten their seat belts, convey key instructions and comforting messages to them, and ensure that the cabin is orderly. Modern passenger aircraft have designed detailed emergency manuals and training programs to prepare for such extreme situations. The crew must also conduct intensive training on the simulator regularly to ensure standardized response and cooperation when both engines fail. Functional design, strict assessment, and professional training are all keys to ensuring that casualties are minimized in the event of an accident. In fact, although in rare cases, passenger planes may be forced to make emergency landings in public places such as highways, considering the huge safety risks, relevant agencies and law enforcement agencies are strongly opposed to this approach. Aircraft emergency landing requires a site of sufficient length and width, and the design of highways is mainly for high-speed vehicles. Therefore, any emergency landing at a venue that is not a dedicated runway will face huge safety risks. This not only endangers the safety of aircraft and passengers, but also poses a threat to people and property in public places. Therefore, even if the aircraft encounters a major failure, the crew should make every effort to land the aircraft safely on the runway of the designated airport or alternative airport, in accordance with standard operating procedures. At the same time, ground units will activate detailed emergency plans and fully cooperate to complete rescue operations. Flight safety is the lifeline of air transportation. To ensure the flight safety of passenger aircraft, we need to start from many aspects. The first is the design and manufacturing of the passenger aircraft itself. When aircraft manufacturers design new passenger aircraft models, they will use the latest technology and materials to ensure structural reliability. During the manufacturing and assembly process, there are strict quality inspection procedures, and every part will be tested to ensure that it meets the design requirements and safety standards. Passenger aircraft also require regular preventive maintenance and replacement of wearing parts to ensure that performance parameters are in optimal condition. The second step is pilot selection and training. To become a qualified commercial airliner pilot, you need to pass layers of screening, undergo several years of high-intensity training, and assess your emergency response capabilities in various situations. Before flying a passenger plane into the sky, pilots must also conduct simulator training to master the performance parameters of the passenger plane and the use of various equipment. Receive new training regularly and understand the latest rules and regulations. At the same time, there is a complete supervision system and operational guarantee. Airlines must establish a complete safety management system, carry out various tasks in compliance with industry and national regulatory requirements, and ensure standardized operations. In addition, the Air Traffic Control Department uses radar and communication equipment to monitor the airspace, command and dispatch, and ensure the safe flight of passenger aircraft. Ground staff are also responsible for safety during aircraft check-in, loading inspection, runway inspection, navigation, etc. In addition, it is a reliable backup system. Modern passenger aircraft have a redundant design. When the main system fails, the backup system can be activated immediately. Key components often use multiple backups, and damage to a single component will not affect the operation of the entire aircraft. The cabin is also equipped with sufficient escape facilities and survival supplies to cope with various situations. More importantly, airlines regularly conduct emergency drills for flight safety accidents to improve the crew's ability to respond. The industry will also summarize lessons learned from accidents and introduce higher standards to further improve system safety. In fact, compared with other means of transportation, the safety factor of modern passenger aircraft is very high. This is due to the continued progress of aviation technology, effective safety supervision, and the joint efforts of the entire industry. Statistics show that the safety level of commercial airliners has always maintained an extremely high standard. According to statistics from the International Civil Aviation Organization, the accident rate of global commercial scheduled flights in 2021 is only 2.4 per 1,000, which is far lower than the accident rate of road traffic. This means that the safety factor for passengers traveling by air reaches 1 in 100,000. With continuous optimization of passenger aircraft design, flight operations, and system supervision, this number is still increasing. Among them, advanced passenger aircraft design provides a solid foundation for safety. Modern passenger aircraft use advanced materials and systems, have superior structural reliability, and can withstand greater maneuvering loads. At the same time, the redundant design ensures flight safety in the event of single-point failure. Electrical and instrumentation equipment also have multiple redundancies to ensure normal operation of the system. The new passenger aircraft are also equipped with more advanced and complete safety protection measures to cope with various emergencies. We also adopt a rigorous attitude during the manufacturing, assembly, and flight testing processes to ensure high standards. These make modern commercial aircraft unprecedentedly safe. In addition, the training and supervision of crew members have become more stringent and standardized. Continuously improve operating procedures, emergency response, human-machine interface design, etc. to reduce human errors. The crew must receive new training and reviews regularly to ensure operational standards. Airlines and regulatory authorities have also established a comprehensive safety management system to determine responsibilities, standardize operations, and continuously summarize and improve it. This effectively controls risks in the aviation system. To ensure the safe operation of aircraft flights, modern passenger aircraft and aviation systems integrate a number of cutting-edge technologies. First of all, in the design of the aircraft, an advanced flight control system is adopted, which can automatically stabilize the aircraft and prevent human operating errors. The cockpit is equipped with a global positioning and inertial navigation system, which can accurately position and automatically fly to a predetermined route. It uses composite materials and fly-by-wire flight control technology to make the overall structure lighter and more maneuverable. Equipped with redundant backup systems, the failure of a single system will not affect the flight. Various early warning systems on board can prompt problems and automatically compensate to avoid accidents. Secondly, in terms of route design and air traffic control monitoring, high-precision satellite navigation was used to establish fixed departure routes and standard arrival routes, reducing manual control and reducing the risk of errors. Using the computer-integrated air traffic control system and precision radar, the ground can control the position and status of each aircraft in real time, coordinate intervals, command and dispatch, avoid weather turbulence, and ensure safe flight. At the same time, at the airport, the echelon light system can accurately guide aircraft taking off and landing. The visibility sensor can display the runway environment to the pilot in real time and decide whether it is safe to take off and land. Using GPS and digital maps, pilots can accurately display the dynamic positions of other aircraft and obstacles in the runway moving area to ensure ground safety. What cannot be ignored is that in terms of maintenance, the use of non-destructive testing and sensor health monitoring technology can predict abnormalities in mechanical parts in advance and proactively replace them instead of waiting until a failure occurs before repairing. This can significantly reduce the probability of system failure during flight. Using predictive maintenance strategies and remote condition monitoring technology, the status of each aircraft system can be assessed in real time and problems can be located and dealt with in a timely manner. It is worth mentioning that in terms of emergency response, satellite communication and positioning technology can be used to quickly locate and rescue a crashed aircraft at any location. The emergency system will automatically report the status when an accident occurs and send detailed data to the ground to help investigation and analysis. These technologies can improve the efficiency and success rate of accident response. In general, cutting-edge technology systems are used to comprehensively improve monitoring, prediction, and response capabilities, effectively ensuring the safe operation of aircraft. With the continuous advancement of relevant technologies, commercial air transportation will be safer and more reliable in the future. On the other hand, in the field of materials science, the application of many new materials and new technologies has greatly improved the safety and reliability of aircraft and ensured the safe operation of flights. First, the widespread use of composite materials makes aircraft structures lighter and stronger, which can withstand greater stress and improve fuel efficiency. Carbon fiber composite materials have high specific strength and high specific modulus and have become the main materials for many aircraft structures and components. Compared with metallic materials, composite materials are lighter, have longer fatigue life, and are more resistant to corrosion. Composite material structures can strengthen key parts from the beginning of the design to improve structural integrity. Digital design and simulation can also optimize the distribution and performance of materials in structures. Secondly, advanced metal construction and processing technology are also further enhancing the structural reliability of the aircraft. The application of titanium alloys and high-strength aluminum alloys allows metal structures to withstand greater stress. Technologies such as laser welding and additive manufacturing make metal parts lighter and stronger. Surface treatment technology also optimizes the material's corrosion resistance. These improvements have improved the safety factor of the structure and key components. What cannot be ignored is that non-destructive testing technology and sensor health monitoring systems make the safe operation of aircraft more reliable. These systems can monitor the integrity of materials and structures in real time, detecting damage before it occurs and preventing accidents. Non-destructive testing includes ultrasonic testing, eddy current testing, and other technologies. Thank you for liking, leaving a message, subscribing, and turning on the little bell. We will update the latest news from around the world every day. Continue to use a scientific perspective to explore the complex truth behind meteorological events.